Math 8 students, what's up? So today we are moving on to the next part of Unit 2, which is scientific notation, okay? The first thing we're going to do is we're going to learn to write in scientific notation, okay? So a couple things you should write down. This is a video, you should probably try to take notes along with it and not just watch the video, whether if it's just the little things jotted down or every single thing I write. But scientific notation is a way to write really large or small numbers. Okay, what I mean by really large is it could be like 83 million. Okay, if you're in a story problem, you really don't want to write 83 million 5 different times and stuff like that, or something that's really small like 0.00000024. Okay, that being said, you could rewrite something like 142 in scientific notation. You could rewrite 0.02 in scientific notation. Okay, but it's designed to rewrite really large or really small numbers. The next thing is, when you write something in scientific notation, the number needs to be less than 10. Okay, so like 1, 1.7, 8.2, 9.9, something along those lines where you just have one number, then the decimal. Okay, so that is scientific notation. We're going to do some examples. 4 examples, I'll do 2, and then you could try 2 yourself, and I'll still go over them and stuff like that. Okay, so first 2 examples. Example 1. We have a large number. I could put my commas in, and you notice it's 4,300,000. Okay, we need to write this number in scientific notation. The first thing we start with is, where is our decimal? Well, if it's just a giant whole number, the decimal's at the very end. So we're going to put that decimal in. I'm going to get rid of the commas just because it's going to be a little bit easier to do that. Okay, I'm going to put my decimal in, and I'm going to move the decimal to where it needs to go. Okay, where it needs to go, remember, it needs to be a number less than 10. Okay, so if I look at my 4 and my 3 here, if I put the decimal between the 4 and the 3, well, that number's 4.3. Is it less than 10? Yes, it also needs to be more than 1 or 1. Okay, but I have 4.3. Now, how I write this is technically times 10. Okay, if you remember from when you learned about multiplying by 10, multiplying and dividing by 10 or 100, 1,000 just moves the decimal, takes away a 0, stuff like that. Like 400 times 10 is 4,000. You added 1 0 because you multiplied by 110. Okay, this 10 is going to have an exponent to it. That exponent tells us 2 things: how far the decimal moved, and what type of number we have to begin with. Okay, so first of all, this is a large number. Okay, a large number is going to give you a positive exponent. A positive exponent means you're going to get a large number, whether you're writing from standard to scientific notation or vice versa. Positive exponent, large number. Large number, positive exponent, means the same thing. Okay, so I know I'm going to have positive exponent, and I'm just going to count. 1, 2, 3, 4, 5, 6 times. So therefore my exponent is a positive 6. And there's my answer. Okay? Again, if you need pause video at any point, pause video. Example 2. Okay? Here, hopefully you can see it. It goes 0.000057. So again, find where the decimal needs to go and move it there. So I need a number less than 10. Okay, so I obviously wouldn't put it at the very end because that would give me 57. I need 5.7. Okay, and then we're going to move the decimal there. So again, 5.7 times 10. Now you notice here, my exponent's probably going to be different. This is a small number, so it's a negative exponent. Negative exponent means small number means negative exponent. Okay, I move it 1, 2, 3, 4, 5 times, so it is a negative 5 as an exponent. Okay, and that's my answer. Again, pause if you need to. I'm going to put up 2 more examples. Try these first. So it means when I come back, pause it, try them first, and then listen to how we get the answers. Example 3. Okay, again, try it on first. Here we go. Okay, I need to put the decimal where it needs to go. If I put it at the very end, that's 345. That's not right. If I put it between the 4 and the 5, That's 34.5, okay? Again, these be less than 10, okay? So 3.45. Don't forget to write down the 5, okay? You need to include everything after the decimal, unless it's just extra zeros at the end. So I'm going to have 3.45 times 10. And again, we notice this is a small number, so it is a negative exponent. Okay, and then we just count how many times we moved it. We moved it 1, 2, 3 times, so therefore it's a negative 3. And there's my answer. Okay, pause if you need to. Otherwise, example 4. Okay, I wrote it just a little bit different. Okay, this is not something you traditionally need to move to scientific notation, okay, unless you're doing something later in the unit, which you'll see. But start with where the decimal's at. Well, it's a whole number, so place the decimal at the end. You're 9,810. Move the decimal where it needs to go. It needs to go between the 9 and the 8. That way we have something less than 10. Okay? So I get 9.81 times 10. It's a large number, even though it's not that large. Technically, a large number could be like 12. That's a large number, okay? A large number is simply something greater than 1. A small number is less than 1. So a small number has the 0 point stuff, large numbers don't, okay? Anyways. Then we just count how many times it moved. It moved 1, 2, 3 times. Since it's a large number, it's a positive exponent. And that is our answer. Okay? That is it for this. Technically, you're going to have a practice. And then next time I see you, we'll be going the opposite way. So we'll be starting in scientific notation, and we'll be going back to standard form, which is just your normal numbers. Okay? So that's it. Hope you have a good one, and I'll see you next time.